Hi, my name is Bay Bryan. I'm in Math 650, and my selected research topic in mathematics is on RSA cryptography. So, first off, I wanted to dive into the history of cryptography. So, cryptography is a new study in science, and it's been studied for around 100 years. So, it's pretty new. But we have records of cryptography predating all the way back to 1900 BC. It hasn't been studied as its own science until 100 years ago. And first off, I wanted to explain the difference between cryptography and cryptology. So, cryptography is the art of creating codes, while cryptology um, is the study of both creating and solving codes. So, they're very similar, that's just the difference. And the first known evidence of cryptography predates all the way back to 1900 BC Egypt. And it was an inscription carved in the main chamber of the tomb of nobleman Kumnahotep II. And it was thought to be a type of cryptography because of the unusual hieroglyphics in place of more ordinary ones. So, usually, when we think of cryptography, we think of someone is trying to hide a message that you can later encode and figure out for the certain person that needs to figure it out. But in this case, they went into more, scientists believe on the tomb that they wanted to more so dignify the message and make the message seem greater rather than hiding a message. And then the next in-depth records we have of cryptography is from 100 BC, and it's called Caesar's cipher, and it was invented by Julius Caesar. And it was a way for him to secretly send messages to his generals in the time of war, which he's the one that started the idea of sending secret messages through war, which will later play out in cryptography for many centuries. And then in 16th century France, Vigenère created the first cipher involving an encryption key. And the ciphertext was produced by adding the message character with the key character modulo 26. And then later on, in 19th century, Hebron created a rotor machine. And this was the first machine ever created to encode ciphers. And it involved a single rotor. And then next was the Enigma machine. And the Enigma machine, which is what I have pictured right here, is it's extremely similar to the rotor machine. It is like a rotor machine, but instead of one rotor, it uses multiple rotors that rotate at different rates as you type on the keyboard, and the output ciphers the text. And then also, I wanted to explain where the term cryptology comes from, and it's developed from the Greek word kryptos lolos, meaning hidden word. And so, next, I wanted to discuss the inventors of RSA cryptography. And so that was cryptography on its own. But these guys invented what we now know as RSA cryptography. And the R, S, and A stand for their initials, which you can see here: Ron, at Rivest, Shamir, and Aldman. And the RSA encryption is a public key-based crypto system, and it's as I already said, it's named after them, and they invented it in 1977. So first off, I wanted to discuss the inventors of RSA cryptography. So the first inventor is Ronald Rivest, which is who you see here on the left. And he's currently an MIT Institute professor and member of MIT's Computer Science and Artificial Intelligence Laboratory. And he's the co-author of The Introduction to Algorithms. And he sold over 1 million copies and has been translated into 14 languages. He also served as the director of International Association of Cryptologic Research. And then the next inventor of RSA cryptography, right in the middle, that's Adi Shamir. He was born in 1952 Israel, and he's an Israeli cryptographer and computer science co-winner. He holds more than a dozen patents related to cryptography and computer science. And his latest accomplishments are receiving the Japan Prize in 2017 in the field of electronics, information, and technology. And then our last inventor, Lynn Aldman, who is on the right, was born in San Francisco in 1945, and he's currently a professor at the University of Southern California in computer science in the computer science department. And Aldman's 1994 paper, Molecular Computation of Solutions of Combinatorial Problems, discussed the first successful example of DNA computing. And in the paper, he used DNA to solve a problem in graph theory involving a 7-node Hamiltonian circuit. He's also been credited with having first used the word virus to describe a malicious software. So all of the men, these guys came together and created RSA Cryptography, and they're very highly accredited, as you can see, scientists. And their RSA cryptography uses digital signatures, and it uses their data encryption scheme relies heavily on factoring the product of two very large numbers, which form a cryptographic key. And a cryptographic key is a secret value used by a computer together with a complex algorithm to encrypt and decrypt messages. So we'll see how they use this later on in our presentation. But first off, I wanted to explain some advantages and disadvantages to their RSA cryptography. And so first off, RSA cryptography is a leading tool for the use of digital signatures in the United States. It's been used by a main company that picked it up that a lot of people know today is VeriSign. So VeriSign uses RSA cryptography in encoding its signatures and stuff for businesses that buy it and use it. And there's also another form of RSA cryptography it's very similar, created in Great Britain, and it's called the GCHQ. And it wasn't picked up until 1997. So it didn't come about until a little bit later than RSA cryptography. And it's one of the main systems used in Great Britain. And then what many scientists complain about, the disadvantages of RSA cryptography, is that it's really slow compared to other encryption systems, and it's not convenient to use if you are wanting to encrypt an entire file. So that's why you see it a lot more for signatures and things of that aspect where you're not encrypting a ton of things. And then it's useful to businesses such as banks to protect customer information and transaction records. So these are the main companies that are using it. And RSA cryptography is difficult to penetrate, but it was tested and proved that it could be done with a lot of effort. And the person that tested and showed is called, his name is Peter Shor, and he proved that in 1994 using the Shor algorithm that quantum computers can break RSA. So the types of cryptography, I wanted to mention the types of cryptography being taught in elementary school because it's really neat to see that cryptography is a concept that can be in certain ways and aspects of it can be taught starting all the way from elementary school. So the concept of ciphers can be introduced as early as the elementary school. And one example that I wanted to explain that I've actually experienced firsthand when I was substituting for a little bit of time last year at Nashville Elementary School was they had what is called an investigation week. So throughout the week, they would give students certain puzzles to try to solve to then eventually lead up to a reward at the end of the week. And so during this investigation week, they gave the students a cipher. And the cipher was a long piece of paper with a bunch of different letters on it. And the students had to try to figure out what the meaning of it was. And one student ended up figuring it out, and he figured out if you take the dry erase marker and then take the paper and roll it around, then you can see letters starting vertically from top to bottom of what it spells out. Another not an elementary, but homeschool teacher created the Caesar shift, which we already discussed upon, for her children to use, which is the picture below here where they can turn it and figure out the message. And then I wanted to explain how cryptography works. So this is the main steps that you would go through to solve cryptography. So you'd use generating keys, and you'd go through each one of these steps to do an actual RSA cryptography problem. And so these are the steps that you would go through. Calculating the totient function using the coprime. And then once you follow those steps, then you can encrypt and decrypt. You can encrypt your the public key and then decrypt the private key using these formulas with the modulus that we've already discussed. And I also wanted to include an example of RSA cryptography. So the example is if you can select two prime numbers. So we selected P equals 53 and Q equals 59. And so the first part of the public key is N, and N is equal to P times Q. So we get 3,127. So we have our N. And now we need to find an E. And E can be any integer, but it just has to satisfy, it can't be a factor of N, and it has to be in between 1 and the totient of N. So here we're going to pick E to be 3. And so now that we've picked E to be 3, we're going to calculate our totient and make sure that E can stay as 3 because the totient just has to be bigger than E. And here our totient is equal to P minus 1 times Q minus 1, which we end up getting as 3,016. And now we calculate the private key, D, and D is equal to K times the quotient of N plus 1 divided by E. And most people, when they're referring to the private key, they write it as D times E equals to K times the quotient of N plus 1. But to solve for D, we can rewrite it as K times the quotient of N plus 1 divided by E for some integer K. And for K equal to 2, the value of D gives us 2,011. And then lastly, we're going to encrypt and decrypt a message. So let's say we want to encrypt hi. So we'll let H equal 8 and I equal 9. And so the encrypted data can be, so 8 and 9, so 89 e to the mod n using our formula. And then to decrypt, and we end up getting that out to be 1394. And to decrypt, we use that formula again to decrypt our decryption formula and then get back out 8 and 9, which is our code hi. And here are my resources. Thank you so much. Also, I wanted to just go back really quick. I wasn't sure how much time I had, but using the decryption formula that we've already stated, then you plug in your 1394 into it, and then what comes out of it is the 89. That's how we got back the 8 and the 9. So then we get 89, which we can look at as two separate numbers, 8 and 9, to get our, and then we can see the 8 and 9 corresponds to H and I to get high. All right, here are my resources. Thank you so much.